Hi everyone, welcome back. Okay, so last time we talked about these, standard units and what we're going to use for those units, what we're going to use them to actually dimension things. So dimensioning and tolerancing standards are developed and maintained by the American Society of Mechanical Engineers. You can actually join that society if you wish. It's good to put on a resume, and it's also just gives some amazing conferences. However, for using these standards, we have to remember something very, very important. Our tolerances, the variation that we allow, cannot be smaller than the accuracy of a distance measurement standard. Okay? That wouldn't be appropriate. Now, why is that? Well, if I'm using my hand to literally build this wooden yoke, okay? I'm saying, okay, well, that's gonna be one palm, that's one span, 2 cubits, one span and 3 digits here. Fantastic. Those are very inaccurate units of measurement. They don't have a really good standard, okay? And because of that, I would not say, well, okay, plus or minus 0.005 inches. It doesn't make sense. What you're using to measure it doesn't have accuracy to 0.005 inches. My palm, I can't divide my palm and figure out what 0.005 inches of my palm would be. So you would not want to use tolerance measurements that are that accurate. They're too small. This brings us back to something we said a couple lectures ago, in that the smaller your tolerance gets, the less people who can actually do that. And the reason is, not everyone has tools that are accurate enough to make something. Okay? Like I said, there's guys who are called the zero tolerance guys. They have amazing tools and amazing training to be able to do things where they can take two parts that look like this. You have a hole and you have a cylinder, and you put them together and you don't even see the line anymore. It's just gone. That takes incredible accuracy, and not everybody has access to that, which is why the amount of places you can actually build your parts decreases as your tolerance decreases and the cost increases. Okay, but now for us, we'll need to have an accurate distance measurement standard to specify and achieve accurate dimensional results. I need to know that an inch is well defined and a meter is well defined. And when people look at this, they'll know what I mean. Otherwise, why am I building my parts? Now, standards are going to provide terminology, symbols, and methods to define and communicate tolerances. This is what this entire course is going to be about. Everything is about these terminology, especially symbols. So many symbols, because GD&T is about being universal. Now, with this, we're going to have a single interpretation of the requirements. But because of that, we have to know what standard we're using. If our product is based on a previous standard, we have to use that standard to determine applicable requirements. Sometimes things get updated, okay? Sometimes things get updated, and you have to know which standard you're using. For example, you're all in college right now. 10 years ago, different courses were required than they are right now. And if you did those courses, you got a degree. However, if you tried to do those exact same courses today, you would not get a degree because the standard has changed. For example, 10 years ago, the associate in engineering didn't exist, which is what I teach a lot of courses in. And so, if I went back in time 10 years and tried to teach an associate in engineering, nobody would know what I'm talking about. So you have to make sure you're using the standard that other people did, okay? What standard are they using? Use that standard to build the part. Okay, so tolerances. Machine quality, among many other factors, affect feature variation, okay? You can't build anything perfect. There's always going to be variation. Like in my handwriting. Hi. Surprisingly enough, I have terrible handwriting, but I do my best. If I was trying to make myself write in Times Roman font, I couldn't do it. I can't write that accurately. So because of that, we have to define what is an essential amount, what is an acceptable amount of variation. Like, you can all tell that that says hi. You probably can't tell that that says hi. Too much variation. This one right here is allowable. Then my writing of allowable, probably not okay. Okay, so tolerances are what specify that acceptable dimensional variations permitted on a feature. When I say feature, I'm meaning like a particular thing, like a cylinder, or a hole, or an edge, whatever it is. However, you do not just go crazy saying, well, I want zero tolerance on everything, because nobody can build that. So it's only should be the accuracy necessary to assemble and function properly. You know, we're talking about, let's see here, a kid's soccer ball, okay? A kid's soccer ball, it doesn't matter if it's inflated all the way. It can be a little bit flat. It'll still work for the kids. It can also be kind of scuffed. It can be banged up a bit. Nobody cares. They're just having a lot of fun playing with their soccer ball. So you have to understand what it's going to be used for, what's its function, and then design tolerances accordingly. So that's all for this time. I'll see you all next time as we continue to learn about GD&T. Have a wonderful day. Bye-bye.